Hello everyone, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungri, MSc MPhil Mathematics from C.D. King Higher Secondary School, Jotsama, Kohima. In the last session, we learned what is a relation and its types, and we solved some of the problems based on relations. And in this session, we are going to learn types of functions. Before that, let us have a short recap on function. What is a function? You have already learned in class 11 function. Functions are nothing but relations. We can define many number of relations between any two sets. Okay, among those which satisfies two special conditions, especially two special conditions, those relations are called functions. Okay, so what are those two conditions? So let me define the function as a relation from a set A into a set B is said to be a function if every element of set A has a unique image in set B. Okay, these two words, every and unique. Okay, every means all the elements in the domain. This is domain. This is our domain. And this is our codomain. Unique, you know the meaning, that is one and only one. One and only one. That is for all element. Okay, so all the elements should have an image in, there is also only one image in set B, that is function. Example, I will show you by an arrow diagram. Let us take a set A and set B. Okay, here let me write 1, 2 and 3, and here maybe A, B, C. Okay, so 1 is related to B, therefore we draw an arrow here, and 2 is related to A, and 3 is related to C. Here we have one more element, that is D. Is it a function? Yes, we have to check for these two words, every and unique. You see here, all the elements in set A is having an arrow, that is, it is related with some element in the codomain, right? So nothing is left out, no extra. So it is a function. And also you see only one arrow is going from each element, so it has only one image. See, 1 has only one image, that is B. 2 has only one image, that is A. 3 has only one image, that is C. Okay, so it is a function. Both the conditions are satisfying, every and unique. Okay, here we have one extra D. Is it making any difference in the definition of function? No. We don't worry about the codomain. The second set we don't worry. Only we think about the first set, the domain. Okay. So sometimes we call this function as mapping also. We can, in short, we can write f is a function from A to B. Okay. So that is for every A belongs to A, there exists. If you write this symbol, it means there exists a unique image B, small b in B. Okay, this is the definition. Please remember this one. Every and unique, that words are very important. And we can write this one as AB belongs to F. This ordered pair belongs to F. That is, it is working, this function is operating on this A to get B. So we can simply write this one, F of A as B. Okay. If you write A alone, that represents the element in the domain. If you put FA, that means this F function is operating on A, right? So this element we will get always in the second set. It belongs to the codomain. Okay. So here we can write this F1 as B. If you write B, what do you mean by that? That is when we give input as 1, then it goes under some function and we get the output as B. That is the meaning. So F1 is B, and then F of 2 is A. When you give 2 as input, it goes under a function and then we get as A as output. And then F3 is C. If you write 1, 2, 3 alone, it represents the elements in the domain. And if you write F1, F2, F3, then that is always from the second set. Usually students get confused with this 1, 2, 3 and F1, F2, F3. F1, F2, F3 always represent the elements from the second set. Okay, already we have seen what is a domain and what is a codomain and range. Domain is 1, 2, 3. Domain has 1, 2, 3, right? That is the first component. And the codomain is nothing but the set B, entire set A, B, C, D. Whether it has mapping or not, we don't worry, but we take all the elements in set B, that is codomain. And range is the elements which are the images of set A. So that is A, B, C. These three elements only have are the images of some elements of A, right? Therefore, we take only those elements which are under this mapping. Okay, so that is range. All right, now let's move on to the types of functions. This all you studied in class 11. Okay, types of functions. The first type is 1 to 1, or you can write 1 to 1 like this. The other name for 1 to 1 function is injective. Okay, the second one is into function. Sorry, many to one function. Okay, 1 to 1 function, in short you can write 1 1 also, or injective function. A function f from A to B is said to be 1 to 1. Okay, if distinct elements of set A has distinct images in set B. Okay, if you take x1, x2, two elements from set A, if they are not equal, okay, if they are not same, different elements you are taking, then its images will be, what do we get the image for this one, x1? So we get fx1, right? And what is the image of x2 under this function f? So we get fx2, right? These two also not equal, different images. If you take two different elements, the images also will be different. That means 1 to 1 relation. Okay, 1 to 1 correspondence. Okay, but when we prove in the problems mathematically, when we get some functions like fx equal to 3x plus 4, so those type of functions you will be getting in the questions. So there, how do we prove it is 1 to 1? We use the contrapositive rule, which you studied last year. That is, what is the contrapositive rule? If P then Q, if the statement is like this, then we prove it like if not Q then not P, isn't it? So we take like this, if fx1 equal to fx2, we have to consider like this and then proceed. We take fx1 and fx2, and if we simplify, we finally, if we could get x1 equal to x2, then f is 1 to 1. In such a way, we prove that f is 1 to 1. Sometimes we may not get this relation. In that case, we can conclude that it is not 1 to 1. So to prove 1 to 1, we follow this method. We take, it means like, if the images of two elements are same, then those elements are also same. That's what we are proving here. It is the opposite way to prove. Okay, let me show you an arrow diagram. Suppose AB 1, 2, 3, 4, and here A, here B, and here C. C 1, 2, B. This is 1 to 1 relation. Okay, sorry, even this one. This is 1 to 1 relation. Suppose if you have an arrow like this, Okay, it is a function, but it is not one-to-one because 1 and 2 have the same image A, right? B is left out. It's okay, no problem. For function and one-to-one, we don't worry about the set B, the codomain, we never care. But here all the elements are related. Yes, it is all under the mapping, right? But here it is not one-to-one. It is a function, but it is not one-to-one. In this case, we call this as many-to-one function. Okay, if it is not one-to-one, then we call it as many-to-one function. One-to-one function is, it should have only one image. Okay, so let us recollect this one. If x1 not equal to x2, then fx1 not equal to fx2. That is the basic definition of one-to-one function. Mathematically we prove if fx1 equal to fx2, we proceed. Then if we could get x1 equal to x2, then we concluded f is one-to-one. Okay, if it is not one-to-one, then we say that it is a many-to-one function. Okay, the next type is onto function. The third one is onto or surjective. The other name for onto function is surjective. Okay, the last one is into function, and the fifth one is bijective. Okay, so onto or surjective. For onto function only, we consider the second set B. Okay, a function f from A to B is said to be onto function if every element in B has or must have a pre-image in set B, set A. Okay, so if you take two sets A, B, so far we consider only the first set, isn't it? Now we look for the second one also. Is it a function? Yes, it's a function because all elements are related and nothing is left out. Therefore, it is a function, and also only one image it has. Okay, and is it one-to-one? No, it is not one-to-one because C and D both are having the same image as 3. Therefore, it is not one-to-one. This is many-to-one. Right? It is a function and it is many-to-one function. Okay, now we will see for this onto function definition. Every element in B has a pre-image in set A. Every element in set B has a pre-image in set A. I already told you these are called images of set A, and these elements are called pre-images of set B, right? Okay, each and every element of B is under the mapping, is taken by this function f, right? Every element of B has been taken by this function f. Otherwise, every element of B is a result of some input, isn't it? Nothing is left out here. Therefore, it is onto. Even in B, nothing is left out. Therefore, it is onto. Suppose if we have a 4 here. Okay, it has no pre-image. It is extra. This is an extra element in the set B, right? It is left out. It is not under this function. So, in this case, we call this function as into. Okay, if it is not onto, we call it as into function. Okay, how we solve in the problems? We have to find out for every y in B, there exists an x in set A such that fx equal to y. Okay, that means y must be taken by the function. Every y from the set B must be taken by the function. It should be a output for some input. Okay, so in questions we prove you will get a function like fx equal to 3x plus 2. We have to write y equal to 3x plus 2. Then we try to write this expression in the form of x in terms of y. Only you have x here and the remaining, the right side full of y. Okay, if we could succeed, we have to check for whether it is meaningful or not, okay, and whether this, if you give any value for y, you get x, and that x will be in our domain or not, that we have to check. If it is so, then we can say that it is onto function. Okay. The last one is bijective function. If a function is 1 to 1 and onto, if a function is 1 to 1 and onto, then we call that function as bijective function. Okay. In this case of onto, this range will be equal to codomain. Okay. Previously we have seen that range is a subset of codomain, but in case of onto function, we have range is equal to codomain. I'll show you only one problem, how to check the injectivity and surjectivity of a function f from n to n. N for natural numbers, you know, right? And given by fx equal to x square. Okay, this is the function defined like this. Let us check for 1 to 1 and onto. Okay, so for x1, x2 belongs to n. This is, I am taking from domain, okay? Domain, x1, x2 from domain. So we have to, suppose, we have to consider like this, fx1 is equal to fx2. These two images are same. In that case, x1 square will be equal to x2 square, right? Fx is x square, then fx1 will be x1 square equal to x2 square. Then you bring this one other side, x1 square minus x2 square equal to 0, a square minus b square, then ax plus x1 plus x2 into x1 minus x2 is equal to 0, right? And this case will not arise because x1 plus x2 is 0, for example, then x1 equal to minus x2. It is not happening in case of natural numbers because our domain and codomain both are natural numbers and we don't have negative numbers here. And it is saying that x1 is equal to some negative number, right? So it is not happening. So we have to avoid this. Then we will take only this x1 minus x2, 0. So in this case, we get x1 equal to x2. Therefore, f is 1 to 1. All right. And then how to show that it is onto. Okay. Let us take a natural number. Let us take 2 belongs to n. 2 is a natural number, right? Okay. Can we get 2 as a result of some square? Is it possible? I want 2 as an answer. When you take a square of a number, you should get 2 as the answer. It's possible only when we take the root 2. Root 2 square is 2, right? It is possible to get 2 as the answer. But root 2, it is not a natural number. It is not a natural number, so we cannot consider this. If we can find out a natural number and if you take the square of it, if you could get 2 as the output, then it is onto. But to prove it is not onto, we have to show just one example. Even for 2 this, we could not find any number satisfying this condition. Therefore, there does not exist any x belongs to n such that fx equal to x square equal to 2. Therefore, f is not onto. Okay, it is 1 to 1 but not onto. For example, fx equal to 3x plus 5. I'll just show you. I'm running short of time, so I'm just showing for this function how to prove onto. 1 to 1 is like this, okay, but onto you have to take this function as y as 3x plus 5. Then we have to rewrite this like y minus 5 equal to 3x and x equal to y minus 5 by 3. All right. Suppose this element, if it is belonging to the domain, then we can say that it is meaningful, right? So if it belongs to the domain, then we can say that for every y belongs to the second set, say b, there exists x belongs to a such that fx equal to y. Therefore, f is 1 to 1. We have to check whether this x value belongs to the domain or not. That is the only thing we have to do it. Okay. Suppose x domain is real number. Domain is a real number. you can give any value of y. So you will get a meaningful result for this, right? So in that case f is onto. So in that way we have to prove it for other functions like fx equal to 3x pi or x squared plus 4, all those. Okay, that's all. Thank you.